Hello class, this is Mr. Steigerwald, and we're going to be taking notes on lesson 4.6, Isosceles and Equilateral Triangles. Our objectives are to use properties of isosceles triangles and to use properties of equilateral triangles. Now the vocabulary. Legs of an isosceles triangle. These are the congruent sides of the isosceles triangle. In the triangle below, triangle ZKP, you can see that by just looking at it, that this is going to be an isosceles triangle and the congruent sides are ZK and KP. These will be the legs of the isosceles triangle, and that is ZK, segment ZK, and segment KP. Go ahead and write this down, the definition, the triangle, and the segment ZK and segment KP. Number 2, vertex angle. This is the angle formed by the legs of the isosceles triangle. So, in example number 1, we said that ZK, segment ZK and segment PK were the congruent parts, so these are the legs. The vertex angles will be formed by this leg and this leg. So the vertex angle is right here, angle K. Vertex angle, angle K. Go ahead and write down the definition along with the triangle and angle K. Number 3, base. This is the side opposite the vertex angle of an isosceles triangle. So we just said that our vertex angle was up here with angle K. So our side opposite, that'll be down here. So that means segment ZP is our base. Segment ZP is going to be our base. Go ahead and write the definition, the triangle, and segment ZP. Number 4, base angles. These are the two angles that have the base as the side. So let's go back to the beginning here. We said that these were the legs. And our base angles are going to be actually across from these legs. So this angle right here and this angle right here are going to be our base angles. It's the two angles that have base as the side. And we said earlier that ZP is our base. So our base angle is angle Z and also angle P. Go ahead and write all this down. Alright, some key concepts here. The first theorem, the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So what they're saying is our base angles are going to be congruent. That'll be angle B and also angle C. So our conclusion is angle B is congruent to angle C. The next theorem is the converse of isosceles triangle theorem. It's the opposite of the theorem that we just did. It states here if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So we see that angle E and angle F are congruent. It's going to be the sides opposite that are going to be congruent. So that would be segment, I'll go ahead and highlight the segment. Segment DE is going to be congruent to segment DF. The conclusion, segment DE is congruent to segment DF. Go ahead and write this down. Corollary. It follows the theorem. The first corollary, if a triangle is equilateral, then it is equiangular. A shortened way here to write this, equilateral triangle implies equiangular triangular. This little arrow right here means the word implies. So we see that with this triangle ABC, since the sides are congruent, we know that the opposite angles are going to be congruent to each other. So we'll have angle A is congruent to angle B, which is congruent to angle C. And that is our conclusion. Go ahead and write that down, please. Bait. The next corollary. If a triangle is equiangular, then it is equilateral. In a shortened version of this, equiangular triangle implies equilateral triangle. Again, that arrow means implies. So just like we did with the theorems up above, since we have these angles congruent, we know that the opposite sides are going to be congruent. So we're going to have segment DE congruent to segment DF, which is congruent to segment EF. And that is our conclusion. Go ahead and write that down. We're done with our notes. See you in class. Bye.